So in our last video, we talked about graph and we did some quick intro about what are graph, what is considered a graph. We gave a couple of examples of what is graph, different terminology like what is a degree of a node. And we did some quick introduction about Networkx, a Python module that lets you work with graph. We did a couple of examples here, and this is the last graph that we generated. So if you didn't watch the last video, I really consider you go and watch it so you can get up to date with this video. So in today's video, we're going to talk about graph traversal algorithm. Like these are the most important algorithm when it comes to graph traversal. So let's get to it. So graph traversal algorithm. So GTA, yeah, GTA stands for Graph Traversal Algorithm. I'm sure you didn't know. So GTA are method to use to visit or explore node or vertices in a graph or a tree data structure. This algorithm, like this graph traversal algorithm, I usually use it to share, traverse, or retrieve data from graph. There are several types of graph traversal algorithm. And today we are going to talk about BFS, breadth-first algorithm. So BFS is a fundamental graph algorithm. It begins with a node in a given node, then first traverse his adjacent node. What do you mean here by adjacent is neighbor, his edges, and basics. Every edge of this node are visited, then the edges become a current node, and we will do the same thing again. We visit the current node neighbor edges, and once that one is also done, we again do the same process again. So BFS guaranteed that the shortest path between two nodes is always taken. So that is what basically, in a nutshell, what is the BFS algorithm. So to implement a BFS, you basically need a data structure that is called FIFO, like first in, first out. Like it is a data structure like a queue or list, basically a data structure where you can retrieve element in the logic of first arrive, first serve. Example, like a line in the bank counter or a line at the cash, like the first person and the line will be served first. So basically that is the principle of BFS algorithm. So BFS traversal algorithm. So let's look at an example. So this is the last graph that we generated. So let's say we wanted to use BFS to traverse this graph. So first we need to start at a starting point. So let's say we start at A, not A. So what we're going to do, so we pick up node A, start by visiting his neighbor. So node A got two edges, so that means that he got two neighbor B and C. So after we treat node A, what I mean by treat, it depends on what you're gonna do. For this example, moving forward, we're just gonna print the current node, but you can do whatever else you want, like modify the value at the node, like depending on your data type. But let's say we treat node A by putting it into the console, then we add his two neighbor in the current queue. So next time that we iterate to the queue, B or C gonna be treated. So it depends on how we declare a graph into the creation. So we add B and C into the queue, and let's say B is our next current node. So we take B. So we visit his neighbor, his edges. B got two edges, D and C. So we add D and C into a queue. So after we finish treating B, we're going to add D and C into the queue, and next time we're going to treat B or C. As you can see here, we add the C twice in our queue. When we was treating node A, we added B and C, And when we added B and C into a queue, and when right now when the colon node is B, we added C again. So that means that in our queue, C going to be treated twice. So we need a way to avoid that. Like we need something to make sure like node A, node E is treated twice in a queue. So after treating B, we're gonna come back to node C and we're gonna visit his edges. We got two, D and E. We're gonna add B and E into our queue. After treating C, we're going to process node D or E. So let's say we get to node D, same thing. We're gonna add his edges. We got one, two, three edges. We're gonna add C, E, and F into our queue. So after treating D, we're gonna go to node E. So also we're gonna add his neighbor into our queue. So after treating colon node E, but as you can see, we already treated node C and D. So these are not going to be processed. And finally, we're going to process node F, and we got two neighbor D and E. So, but D and E again are already treated. So our algorithm will stop right here. So let's just go in this example one more time, but sometimes we say animation. So again, we start at node A, we visit his neighbor B and C, we add it into our queue, like the queue mean the next node that we're going to process, so that will be B and C. So after finishing node A, we go into our queue, like we have B and C into our queue. Let's say B was first, so we're going to treat node B. We're going to visit his neighbor D and C, and we're going to add those neighbor into our queue. But as you can see, like I said earlier, node C was added twice when we were processing node A, and now with our colon node B. So we need a way to not treat a node twice. So after node B is finished treating, node C gonna be treated like node C got like three neighbor B, D, and E, but as you can see, B was already treated, so there is no link to node B. So we're gonna add D and E into our queue. And next we're going to treat node D. As you can see, we got three neighbors C, E, and F. And since node C is already treated, we're going to add E and F into our queue. And next colon node is E, but as you can see, only F is highlighted because B and C is already been chosen. So we're going to treat node F, and as you can see, that's it. It's already been treated. So let's see this again into a animation, a GIF. Like as you can see, node A, node B, and C and D, E and F. So that is basically the BFS algorithm, breadth first search. That is how it is processing. So let's go right now and implement our algorithm. So let's just open a new notebook, sorry. Mm, okay, let's just do our import again. Let's see. Okay, let's just save now and just run it. As you can see, again, if all these libraries are already installed, you will have no problem. So first of all, let's write our BFS algorithm. So let's just make first our graph representation like we did in our first video. So this is our graph. Just copy it, paste it here. This is the graph that we're going to work on. So let's just create a function called BFS. That's obviously gonna take a graph and a starting point because we need to start somewhere. we can start at node A, node B, node C, which node we want. So for simplicity, let's just start at, let's just make a start here. So like I say in this here, to implement BFS, we just need a data structure that is basically first in, first out. So we can use a queue. There is a queue in Python, or we can just simply use a list. So let's create a queue. Okay, that will be a starting point, like the node that we're going to process first. And also we need a, let's say, a list or something to make sure that we are not treating a node twice. So something that makes sure that we're not visiting a same node twice. So let's just do visited. We can also make it a list again. So, and let's just add another variable like path that's gonna show us our traversal. So, uh, our algorithm need to iterate like every time there is a element to thread in a queue. So while there is a element in the queue, right here, first let's just print that element into our that is into our queue right now. So colon node do that. It's just queue right here. Then we just need to, since this node is processed, we just to remove it into our queue. So there is a function called in this path that retrieve and remove the first element here like this. And then we need to visit his neighbor, the neighbor of the current queue. So for every, let's say, edges in a graph at not our current node, for every edges, but we need to check like if the node has already been treated. So if our edge is not in visited is not already been treated, so add it into a queue like here. That happen, we're going to add it into a queue, and we're going to add it into a visited that happen edges. So in that way, we're going not to treat them not twice. And after treating them, we just maybe add it into a path, like path happen. Let's say I'll put on node, let's say like this, and I'll put on edge like this. So I think then we can return the path. I think that's it. Or maybe we can just print like edges like this, edge into the cube like this. Um, let me see. Yep, we got a queue. We got a visited list. We got a path. So while there is a element into a queue, we print that, we treat that node, then we remove it into a queue. We process his neighbor. We check if our neighbor has already been visited. If not, we add it into a queue and we add it into a visited edge. I think that's it. And after that, we can just return path. Let's say that path. I think everything is good. So okay. So let's just test our function. So let's just call it BFS. Okay, let's print our result. BFS. And we just add our graph here that we declare here. And we just need to add a starting point. Let's say not a stop. We can run it to see. Mm. Oh, I forgot to. Okay, here. I think it should be good now. Okay, let's run it again. Okay, as you can see, we start at node A, a current node, then we add a neighbor B and C into our queue. Now our current node gonna be B and C, and now node B is our current node. We add his neighbor into our queue. As you can see, everything here is printed to add more detail. As you can see, this is a we start at node A, we visit his neighbor B and C. After that, B and C are added into the queue. So B gonna be treated first. We add his neighbor A and C, then so on and so on. So basically, this is the BFS algorithm. But since we come here to talk about NetworkX, we can use that to just do the same thing. So let's just create our graph using NetworkX, like graph, and we can pass in graph dictionary this here that will create the graph here. And to see the BFS traversal, there is a function in NetworkX called BFS Edge right here that can do the same thing. You give the graph after you give a source, a starting point, and there is other options, so on and so on. So let's call that function. Let's go and next that BFS Edge graph and a starting point A. And let's just, since we return a dictionary, let's just return it as a list. So if we run it, we should have the say. Basically, output here is there is no mistake. So as you can see, but this is basically the same as here. It's just like we just make it here more verbal so you can see exactly what's going on. But if I just did that, see right here and run it again and again here. As you can see here, basically we have the same output here. So that is basically the same thing. But the beauty is when you use NetworkX, you don't need to implement it by yourself. You can just simply call the function BFS Edge to have the same thing. So that is BSF algorithm, breadth first search algorithm. So that is it, guys. That is honestly all I wanted to talk in this video. A introduction about graph traversal algorithm and talk about BFS. Obviously, there are other graph traversal algorithm that I'm going to talk about into another video. So that is it. That is all I want to talk about. So if you like the video, please like and subscribe. That'll help me a lot. So that's it. See you next week, guys.